This video covers section 6.8, and in it we will be using some of the methods we have been learning in chapter 6 to solve some different application problems that involve quadratic equations. So let's take a look at the first example. It says the sum of two numbers is 20 and their product is 96. Find the two numbers. So what are we looking for to solve? What are we trying to find in this case? We're trying to find the two numbers. So let's go ahead and use some variables to find those. Let's say x is the first number, and then our other variable y, let's call that the second number. Although, again, as usual, you could pick any variables you like. And then it tells us some information about it. The first thing it says is that the sum of the two numbers is 20. What does sum mean? What operation is that? Hopefully you're thinking that means to add together. So if we add x plus y, their sum is 20. What else do we know? We know that their product is 96. What operation is product? Product is multiply. So that means if I take x times y, the product is 96. Now, back in chapter 4, when we had two equations with two unknowns, remember we used those to the systems of equations to solve those problems. And look, we have these here. Now these aren't both linear, but I should be able to do something like take this equation, move the x to the other side, so it becomes y equals 20 minus x, and then do what with it? I can substitute. I can take this 20 minus x and plug it in for y, substitute. And when I do that, this equation becomes x times y, but y is 20 minus x equals 96. And then, of course, what do I have to do next? I have to distribute. So this becomes 20x minus x squared equals 96, and now you should see that we have a quadratic. That term right there, that tells us it's a quadratic, and we just learned in section 6.6, the last video, that the way we want to solve those is by moving everything to one side, setting equal to 0. So if I move 0 on this side, and I move these two terms on the left to the other side, that minus x squared becomes a positive x squared, and this positive 20x becomes a negative 20x, and we have the plus 96. And then once we set it equal to 0, what do we do next? We factor. So this is going to be, if you factor it, this is going to be x minus 8 and x minus 12. And then we set both of those equal to 0, so x minus 8 equals 0. And then the other one is x minus 12 equals 0. Moving the 8 over, we get x equals 8. And x equals 12. And those really are the two numbers, because don't 8 and 12 add up to 20? 8 plus 12 does add up to 20, and 8 times 12 is 96. So, of course, you could take this number, for example, and plug it in here, and you would see, oh, well, this is 20 minus 12, which is 8. Either way, the numbers are 12 and 8. Okay, so there's one example. Let's go ahead and do one more here. So it says the area of a rectangle is 150 square inches. If the length of the rectangle is 5 inches less than twice the width, find the dimensions of the rectangle. And I always think it's a good idea to draw a picture here first. Here we have rectangles. Draw a picture of what that looks like. So we know we have length, length, width, width. It tells us the area of the rectangle is 150 square inches. And you will recall, what's the formula for area of a rectangle? Area equals length times width. In other words, we know the area though. The area is 150 and that has to be equal to the length times the width. It gave us area right here. Area is 150 square inches, so that goes right there. And then, do we have any other information that was given to us? It says the length of the rectangle is 5 inches less than twice the width. Can we write an equation for that? The length is, so L is what? Is equals 5 inches less than, that means we're subtracting 5. Subtracting 5 from what? 5 inches less than twice the width. 2 times W. And much like the last problem, what are we going to do with that L equals 2W minus 5? We are going to substitute. So you can take that and plug it in for L. And so this equation becomes 150. 150 equals L, but L is 2W minus 5. We still have the W on the end. Again, we distribute. So we have 150 equals 2W squared minus 5W. And again, we see W squared. What does that mean? Quadratic equation. So we need to move this 150 over with the other terms. So we have 0 equals 2W squared minus 5W minus 150. And this is factorable. It's a little bit harder to factor, but with a little work, I'm sure you could get it. It's 2W plus 15, and then W minus 10. This first factor is going to give us a negative answer, so we don't really care about that one, because when we move that over, that makes 2W equals negative 15, or a width of negative 7.5. That's not a reasonable answer. But the other one, the W minus 10 equals 0, that tells us that the width is what? The width is 10 inches. And then how can we figure out the length? We've got to figure out the dimensions. That means the length and width. Well, we already found up here that the length is 5 less than twice the width. So if we take 2 times the width of 10 inches and subtract 5, we get 20 minus 5, or 15 inches. So the dimensions are, length is 15 inches, and the width is 10 inches. And that should do it. Make sure you complete your self-check. We'll see you in class.